explain more about the structural engineering. Structural engineering is a sub-discipline of civil engineering in which structural engineers are trained to understand, predict, and calculate the stability and strength and rigidity of built structure for building or non-building. This is to develop design and integrate their design with that of other designers, and to supervise construction of projects on site. They can also be involved in the design of machinery, medical machinery, and vehicle where structural integrity affects functioning and safety.
In this department, we will focus more on Newton's law. This is because Newton's law are very important and should be considered when we want to build or construct a building. We can see the importance of Newton's law later from the explanation. Newton's law, also known as action and reaction. For example, if certain buildings are not stable enough, it can't resist the action from the wind, and as a reaction, it will collapse. For better understanding, I will demonstrate that situation. I will represent the action from the wind, and she will represent the reaction from the action. In conclusion, we should consider and apply the Newton's law whenever we want to construct a building, so that we can prevent the building from collapse and also for our own safety.
Newton's law. Newton's law is divided into three. The first one is Newton's first law, and the second one is Newton's second law, and the last one is Newton's third law. Newton's first law states that an object will remain at rest or uniform in motion in a straight line unless acted upon by an external force. For the example is inertia. Newton's second law states that the acceleration of an object is dependent upon two variables. The first one is the net force acting upon the object, and the second one is the mass of the object. The formula related to this second law is F equal to ma. Newton's third law states that all the forces in the universe occur in equal but oppositely directed pairs. This means that for every external force that acts on the object, there is a force of equal magnitude but opposite direction which acts back on the object which exerted that external force.
What is hydraulic engineering? Hydraulic engineering, as a sub-discipline of civil engineering, is concerned with the flow and conveyance of fluid, principally water and sewage. One feature of this system is the extensive use of gravity as the motive force to cause the movement of the fluid. This area of civil engineering is intimately related to design of bridge, dam, channel, canals, and levees, and to both sanitary and environmental engineering.
Hi, my name is Amir. This is a Powtoon video on hydraulic department. Today, I'm going to talk about coastal erosion. There are 6 types of threats in the coastal zone: beach and coastline erosion, river mouth sedimentation, extreme storms, sea level rise, tsunami, wave and inundation, environmental threats such as oil spill and depleted ecosystem. Beach and coastline erosion. Why do beach erodes? There is a pattern of supply and demand of sediment within a particular coastal cell. Types of coastal cell. Surplus, balance, deficit, Coastal erosion protection strategies. Seawall made of rock, concrete or sand filled back. It is basically barricade the beach and coastline infrastructures from waves. Groin made of rock, concrete timber or composite steel. Constructed across the surf zone of the beach, it traps sediment within two groin but may hinder water circulation. Detached breakwater, a small elongated island parallel to the beach line. It is suitable where the dominant wave is 90 degrees to the coastline. Submerged breakwater, made of rock and concrete. It is built to allow wave to break above it. Some designs incorporate artificial reef functions. Beach nourishment. Sand is imported to balance up the transport process. It requires monitoring and maintenance. It might be detrimental to the local beach ecosystem due to foreign beach material.
What is environmental engineering? Environmental engineering is the branch of engineering concerned with the application of scientific and engineering principles for protection of human populations from the effects of adverse environmental factors, protection of environments both local and global from potentially deleterious effects of natural and human activities, and improvement of environmental quality. What is meant by flood? Flood is an overflow of a large amount of water beyond its normal limits. Sometimes floods are caused by human activities such as dumping in the rivers and so on. This is called flash floods. There are many ways to overcome flood. Here I have listed 6 ways to overcome floods. The first one is by introducing better flood warning system. By having a better warning system, it gives people more time to take action during flooding, potentially saving lives. Next is modifying homes to help them withstand floods, which means the focus should be on resilience rather than defense scheme. This shouldn't be a problem because we are living in a modern world with modern technologies. The third point is constructing buildings above flood levels. Flood damages can be prevented if building were to build 1 meter above the ground. After that, we must also tackle climate changes. Constant raining and melting of iceberg can also cause flood. Therefore, we must look into weather conditions in order to avoid flood. Number 5. Protect wetlands and introduce planting trees strategically. Creation of more wetlands, which act as sponges soaking up moistures, and more wooded areas can slow down water when rivers overflow, therefore preventing floods. Lastly, we must also restore rivers to their natural courses as they had been straightened. Bending the rivers once more increases the length and can delay flood flow and reduce the impact of flooding.
Geotechnical engineering is the branch of civil engineering concerned with the engineering behavior of earth material. Geotechnical engineering is important in civil engineering but also has application in military, mining, petroleum, and other engineering disciplines that are concerned with the construction occurring on the surface or within the ground. Geotechnical engineering use principle of soil mechanics and rock mechanics to investigate subsurface conditions and materials, determine the relevant physical or mechanics and chemical properties of this material, evaluate stability of natural slope and man-made soil deposits. assess risk posed by site condition, design earthworks and structure foundation, and monitor site condition, earthwork and foundation construction. What you see is the process known vacuum consolidation. It is to stabilize the underlying soft soil. This technique involves inserting the special pipe into the underlying soft ground to the required depth. This pipe connected to the large vacuum hubs, the heavy type membrane on the surface to shield it and create the vacuum which help to remove the water and air from the soft soil. What you see is the process known deep soil mixing, which is strengthened the soil by adding cement or lime and put into the ground to the required depth. When reached to the required depth, binder is injected. As it have rice, cement or lime mixed with the soil and become the rigid column which then able to support the loads. You see here is the wick ring. The wick is actual plastic cover with actual fiber to filter the water from the soil. This wick ring being inserted into soft soil to make it easier to extract the water. The wick is drilled down to a required depth in the soft soil. The surcharge on the top of the wick in the soft soil forces the water out of the soil by the wicks. What you seeing here is stone columns is being built in the soft soil. The vibrating pipe send the tube to the bottom of soft soil. Small stand and pump through into the tube. The process involves pushing the stand down to form the column, which is vibrated and compacted it all the way to the surface. This column can be main support the loads on the surface.